Okay, we're going to run through the study guide. This is chapter 3, the second half of chapter 3. I'm just going to run through the questions really quick and show you how to work through them all. So first one, number 1, we are going to find all of our like terms. So let's see, the real numbers are 5 and 14. We're going to add these numbers together. 5 plus 14 is 19, and then negative 7i plus negative 6i is negative 13i. Problem number 2, I'm going to start by distributing the 3 first on the first set of parentheses to make 18 plus 24i. I'm going to distribute negative 7 on the second set of parentheses, giving me minus 14 plus 35i. And then we'll combine the like terms together. So we get 4 plus 59i. Question number 3, we have to multiply these complex numbers together. So we're going to run through distributive property or FOIL if you prefer that. So 7 times 3 is 21. 7 times negative I is negative 7i. I times 3 is 3i. And I times negative I is negative I squared. Our like terms right here are going to make 21 minus 4i. Here, the I squared needs to be replaced with negative 1. So it is minus, and then the I squared is negative 1. So that becomes plus 1. And that's going to combine with the 21 to make 22 minus 4i. Question number 4, we'll do the same kind of work. 8 times 9 is 72. Next we got 24i. On the inside we have minus 36i. And at the end we've got negative 12i squared. Okay, so let's fix the I squared. So I squared is negative 1, which is going to flip that minus 12 to plus 12. So our like terms are 12 and 72, so 84. And then our i's are going to make minus 12i. Okay, next problem, 5 minus 4i cubed. So a lot of people miss this the first time on the test because of the third power and knowing what to do with the third power. I would start by expanding where the third power is. So I'm going to rewrite this as 5 minus 4i times 5 minus 4i times 5 minus 4i. Okay, you can only multiply 2 of these at a time. So just pretend that the third one's not even part of the problem to begin with, and start by multiplying on these first 2. So run through your distributive steps. 25 minus 20i minus 20i plus 16i squared. And that 16i squared is really like a negative 16. So 25 minus 16 is 9. And our 2 I terms combine to minus 40i. Okay, now we have to bring this 5 minus 4i down that we've kind of saved up until now. Now we're going to multiply again. So 9 times 5 is 45. 9 times negative 4i is negative 36i. 5 times 40i is negative 200i. And negative 40 times negative 4 is plus 160i squared. That I squared is negative 1, so it changes that 160 to a negative 160. So our like terms, 45 minus 160 is negative 115. And our i's, combining those, minus 236i. Question number 6, rewriting powers of I. So the way to do this is to divide the power 34 by 4. 4 goes into 34 8 times, which is 32. Subtract is 2. The remainder is what we're after. So that tells us that I to the 34th power is the same as I to the second power, and I to the second power is negative 1. Okay, same process over here. I'm going to take 135 divided by 4. 4 goes into 13 3 times. And then 4 goes into 15 another 3 times. That is the remainder, 3. So I to the 135th power is the same as I cubed, which is the same as negative I. Okay, next one, absolute value of 3 minus 9i is from Pythagorean theorem, but it's simply the square root of 3 squared plus negative 9 squared, which is the square root of 9 plus 81, which is the square root of 90. And kind of scratch work if you need out to the side. 90 is 9 times 10, and we can square root the 9. So we end up with 3 square root 10. Next problem, we're going to have the square root of 8 squared plus 14 squared. Well, that's the square root of 64 plus 196, which is the square root of 260. So out here, scratch work, I'm going to try and break down 260. It's going to be 4 times 65. And let's see, 65 is just 5 times 13, and those are not perfect squares. So I'm just going to use 4 times 65, and I get 2 square root 65. Okay, question number, should be 10. It's labeled 15. And I believe the directions are to, I'm actually not sure what the directions are. I probably need to look this up so that I don't mess up how we're solving it. The directions say to solve with completing the square. So, completing the square, we're going to have x squared plus 12x, moving the 40 over here, and then we're going to add to both sides half of 12 squared. So half of 12 is 6, and 6 squared is 36. That then factors as x plus 6 squared equals 76. And if I take the square root of both sides, we end up with x plus 6 equals plus or minus 76 is 4 times 19, so 2 square root 19. And then we'll minus the 6, so we get negative 6 plus or minus 2 square root 19. Okay, next one is also a completing the square problem. So I'm going to start by isolating the x's. We're going to add to both sides. Half of negative 8 is negative 4, and negative 4 squared is 16. So now we have quantity x minus 4 squared equals 12. We take the square root of both sides, so x minus 4 equals plus or minus 2 square root 3. And then we add the 4, we get x equals 4 plus or minus 2 square root 3. Okay, next problem. I believe these are going to say solve using quadratic formula. So quadratic formula is x equals negative b, so that's going to be 14 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, I don't want to mess this up, so I'm going to grab a calculator real quick just to make sure that the math is good under that square root. So we want negative 14 squared minus 4 times 1 times 6. I'm going to end up with 14 plus or minus the square root of 172 over 2. And can 172 be simplified? It can. So I have 14 plus or minus 172 is 4 times 43. So that's going to be 2 square root of 43. I apologize, the board is glitching, so the pen's not writing very smoothly. And then we're going to reduce, divide by 2. Oh boy, that should be 7. Divide by 2, divide by 2. So we're going to end up with an answer of 7 plus or minus square root 43. Okay, next one, also quadratic formula. So x equals negative 12 plus or minus the square root of 12 squared minus 4 times 3 times 2 all over 2 times 3. I'm going to work out the square root part. 12 squared minus 4 times 3 times 2. So I end up with, next, negative 12 plus or minus the square root of 120 over 6. 120 can divide by 4. Right? 120 is 4 times 30. And we can square root the 4. So we'll get x equals negative 12 plus or minus 2 square root of 30 over 6. I want to finish by reducing. All these numbers divide by 2, so that's going to be 6, 1, 3. So it looks like our final answer is negative 6 plus or minus the square root of 30 over 3. Okay, next, another quadratic formula problem, I believe. Actually, here the directions just say solve with any technique. Okay, so that's actually a little bit easier because I noticed that I can multiply to 10 and add to 11. I can factor this, x plus 10 and x plus 1. So we get x equals negative 10 and x equals negative 1. I apologize, the board is definitely glitching and lagging a little bit, but hopefully we can still read well enough. Next question. Okay, so here we're going to start by moving the 100 over. So 4 quantity x minus 5 squared equals negative 100. Divide by 4. That cancels out. We get x minus 5 squared equals negative 25. Now we can take the square root. We got x minus 5 equals plus or minus 5i, and add the 5 over, so x equals 5 plus or minus 5i. Next one, 16. So let's see, checking to see if this can factor. And it can. So we got x plus 16 and x minus 11. 16 times 11 is 176, and if the 16 is positive, it's going to add to the positive 5. We get x equals negative 16, and x equals 11. Okay, the last two problems are inequalities. These should be fairly easy to solve as far as factorable goes. X plus 4 and x minus 3. So our solutions are negative 4 and 3. Those are going to be our number line points. Okay. Now we are going to use closed circles because the equal to. And then the graph of our parabola looks like this. Now I want to know where is the parabola greater than, which means above the number line. It's above the number line over here and also over here. So our solution should be negative infinity to negative 4 with a bracket, or 3 to infinity. Last problem, also going to be factorable. We got x minus 7, x minus 4. So we get x equals 7 and negative, hold on a second, 7 and should be positive 4. So on my number line, I'm going to want 4 and 7 arranged in that order. There's an equal to, so we want solid points. The parabola coming through the number line like so. And we want less than 0, which is where is it below the number line? So everywhere between 4 and 7, including the 4 and 7, by putting them in brackets. Okay, that is the end of the study guide. I hope that helped prepare you for the test.